Okay class, in this video we're going to find the area inside the cardioid, 1 plus cosine of theta. So I went ahead and graphed it. This is what it looks like. Of course it's centered on the x-axis and it's symmetrical. It has x-axis symmetry. Points to the right. Okay, so per our formula for area, one half integral from a to b of r squared d theta. Alright, so that makes it pretty simple. This is what r is. It takes all of 2 pi to graph this, so this is just going to be 1 half integral from 0 to 2 pi of 1 plus cosine theta whole thing squared d theta. Alright, so that's the integral we have to do. So before we can do that, we need to multiply that out. So this is going to be integral from 0 to 2 pi of 1 plus 2 cosine theta plus cosine squared theta d theta. Okay, and then I'm going to distribute the integral through all the pieces. Okay, notice the cosine squared. So we want to remember the half angle identity. Cosine squared theta is 1 plus cosine of 2 theta all over 2. Okay, so we're going to be using that identity for that cosine squared right there. Okay, so we have 1 half integral from 0 to 2 pi of 1 d theta plus 1 half integral 0 to 2 pi of 2 cosine theta d theta. Okay, and then plus 1 half 1 plus cosine of 2 theta over 2 from 0 to 2 pi d theta. Alright, well that looks really complicated, but what's the period of cosine? It's 2 pi. That's integral from 0 to 2 pi, so that is going to be 0. And let me break this up one more time. Okay, so we're gonna that's 0. We're gonna break this into 2 integrals. So one of them, well, the first one is just gonna be 1 half integral from 0 to 2 pi of 1 d theta. So that's the same thing we started with. And then over here I have a 1 half times another 2 in the bottom. So that's gonna be 1/4 integral from 0 to 2 pi of 1 d theta. And then we have 1/4 integral from 0 to 2 pi of cosine of 2 theta d theta. Well, once again, what is the period of cosine of 2 theta? The period is pi, and that's 2 whole periods, which meaning it's equal above and below the x-axis, so that's going to be 0. Okay, don't expect this to always happen, but it's nice when it does. So putting all these together, this is 1 half times 2 pi plus 1/4 times 2 pi. Okay, and that's just going to be pi plus pi over 2. So my answer is 3 pi over 2. And that is the area inside of said cardioid here. Wouldn't have guessed it, but 3 pi over 2.